Up next, we're going to look at parametric equalizers. The term parametric refers to the fact that this type of EQ has additional parameters that can be manipulated. On our graphic EQ, each fader is set to a specific frequency, and all you can adjust is the amplitude, up or down. On a parametric EQ, there are more options. In addition to being able to adjust the amplitude of our frequencies, parametric EQs also allow us to move the frequency point that we're adjusting. So let's look at an example. So here's a knob for adjusting our amplitude. It's doing the same thing as the faders on the graphic EQ, just shaped differently as a rotary knob control instead of a slider. You can see that if we turned it to the right, we would turn up the amplitude or the loudness. And if we turn it to the left, we will turn down the amplitude or loudness. And then on our parametric EQ, we have another knob for the frequency. This one is going to let us adjust the frequency of the mid-range. We can choose a position anywhere between 250 Hz and 6.3 kHz. Wherever we point the knob will determine the frequency that the amplitude knob boosts or cuts. My console here has parametric EQs. The real advantage of a parametric equalizer is that it allows you to scroll through the frequencies or sweep through them one after the other to find exactly the range you're looking for. So let's give this a try. I've actually got some music queued up, ready to go. So I'll just start it playing and then I can fade it up into our mix. Now we can turn the amplitude of the mid-range up all the way and then sweep through the frequencies from one side to the other. And if we put that back, we can move down to the low band, turn that all the way up, and sweep through from the bottom and up. And now we can do the same with the high frequency. And this way we can listen to all of the frequencies one at a time as we sweep through them. And that's how you sweep for a frequency with a parametric EQ. So this EQ on my console is only called a semi-parametric equalizer because it only has 2 parameters in 3 bandwidths that you can sweep. A fully parametric equalizer will have the frequency control that lets you sweep on the high, high-mid, low-mid, and low bands. This way you can sweep all the way across the entire spectrum. And this will let you find the exact frequencies that you need to adjust. Now, a fully parametric equalizer will also let you adjust the bandwidth, which means the width of the range of frequencies that you're adjusting with the amplitude control. This is called the Q width. You can use your Q control to make the width of a band wider or tighter. If we look at this on our spectrum graph from 20 Hz to 20 kHz with 1K in the middle, and we boost at 1K, this control will let us choose how many frequencies on either side we are manipulating along with our center frequency of 1K. More frequencies or less, wider or tighter on the spectrum. Now you have to watch out because this control is based on physics and electronics and ultimately math. The control itself is specific to the math involved, and so some kinds of equipment will label them differently. You might look at a knob on your console and notice that there's a higher number to the left and a lower number to the right on your Q control. In this case, the higher number actually means a tighter Q, and the lower number means a wider Q. Sometimes manufacturers and designers are kind enough to include a little drawing of a tight peak or a wide curve to remind us, but sometimes you just have to know a higher number Q width is a tighter bandwidth. And now you know. A filter is a type of EQ that restricts the frequencies above or below a specified point. So on our spectrum, we could have a filter restricting the low end or the top end of our signal. When we filter out the low end, we are allowing the high frequencies to pass. And we call this a high pass filter or a low frequency roll-off. We are rolling the lows off or letting the highs pass, but both result in the same effect of reducing the low frequencies. This is great for quickly removing unwanted sounds, like wind noise or air conditioner hum, or even ground hum in your system. It's also great when someone talking directly into a mic says words with P's or B's, and you get that rush of air over the mic that makes a rumbling sound. You can quickly filter out those low rumbling frequencies with a high-pass filter. You'll often see it drawn on your switches and buttons on your console as just a little line that looks the same as your frequency spectrum chart. Now, at the other end of the spectrum, you have the high frequency roll-off, or the low-pass filter, which restricts the high frequencies and allows the lows to pass. This is a quick way to eliminate high frequency feedback, or take out that high hiss that's sometimes caused by the noise floor, or even the sounds made by fluorescent lighting or electrical power supplies that sometimes get picked up by microphones. A switch for a high frequency roll-off or low-pass filter will have a little diagram that looks like this. Again, looks just like our spectrum chart when we're using this switch. And then you'll also encounter a type of EQ called a shelf. And this is just the boosting version of a filter, where you can shelf up the low and high bands above or below a specific frequency point. This can be helpful to create deep sub-resonances, or to add air and clarity to high fidelity content. It's also worth noting that these filters are sort of on the road to becoming kind of obsolete. There are a lot of plugins and types of equipment being made using AI, and other high-tech algorithms, which can identify these unwanted sounds and remove them automatically, or identify desirable bandwidths and boost them automatically, without us necessarily having to understand the process. However, you'll be at a huge advantage when using these devices if you actually know what they're doing and why. There will always be value in knowing the physics and technology behind the convenient modern tools. This will allow us to make the best and fastest decisions on how and where to use them.